Tracking comes in two versions: output tracking and integral tracking. Output tracking provides smooth transitions from manual operations to automatic operations. Integral tracking prevents reset windup. Output tracking is the subject of this video. Integral tracking is the subject of a subsequent video. When not active, output tracking does nothing. When active, output tracking performs three actions. First, the output of the PID controller is set to a specified value. Second, the PID control calculations are suspended regardless of the mode of the PID controller. Third, the PID control equation is initialized by performing the same bumpless transfer calculations required when switching the mode from manual to auto. To execute output tracking, two items of information are required. The state of a Boolean or discrete variable determines if output tracking is active. If active, the value of a numerical or analog variable becomes the output of the PID controller. Implementations of output tracking differ from one process control system to another. One approach implements output tracking under the hood. When tracking is required, a PID block receives a track request that is accompanied by a numerical value for the controller output. An alternate is a what you see is what you get approach. The PID block provides two inputs that must be configured for output tracking. The simulator configures output tracking in this manner. Despite different mechanisms, the actions performed for output tracking are exactly the same. Let's start with the scrubber duct inlet temperature controller. As noted in a previous video, we are providing the manual mode of operation by switching the valve block to local. To achieve bumpless transfer, we must configure output tracking in the PID controller. When must output tracking be active? When the valve block is in local. What is the appropriate value for the controller output when output tracking is active? The output from the valve block expressed in the engineering units of %open. The mode of the fuel gas valve is displayed below the symbol for the valve. Currently the mode is remote, so output tracking is doing nothing. Switch the fuel gas valve to local. The scrubber duct inlet temperature controller is now tracking. The mode of the controller is still auto, but with output tracking active, the PID control calculations are not being performed. How do we know that the controller is tracking? The simulator displays the mode as AUT star instead of auto. Commercial control systems provide a mechanism to indicate that a controller is tracking, but these differ from one system to another. Change the opening of the fuel gas valve to 87%. The output of the scrubber duct inlet temperature controller also changes to 87%. It will remain at 87% as long as output tracking is active and the output of the valve block is 87%. The scrubber duct inlet temperature is above its set point of 80 degrees Celsius. Under these conditions, the PID controller would normally be reducing its output. However, the PID control calculations are not performed when output tracking is active. Let's examine the output tracking configuration for the scrubber duct inlet temperature controller. First, switch the controller to manual. The indication MAN star means that the controller is in manual but is tracking. Open the point window. Then open the configuration window for the controller. Select the Initialization Tracking tab. Let's focus on the two specifications for output tracking. Integral tracking will be considered in subsequent videos. Track output when is configured as a false value for FCB fuel.remote. Output tracking will be active when the valve block for the fuel gas valve is not on remote, That is, the fuel gas valve is on local. Value for output is configured as fcvfuel.mn. This is the output of the valve block expressed in % open. If the valve block is on local and its output is changed to 87%, the output of the PID controller also changes to 87%. Click the Cancel button to close the configuration window. Also switch the scrubber duct inlet temperature controller to auto. The valve block is on local, so tracking is still active. Opening the fuel gas valve to 87% has increased the scrubber duct inlet temperature to 82.3 degrees Celsius. PV tracking is not enabled in the controller, so the set point remains at 80 degrees Celsius. The objective of output tracking is to achieve a smooth transition from manual operations to automatic operations. Switch the fuel gas valve to remote. The scrubber duct inlet temperature controller resumes its control calculations. To restore the scrubber duct inlet temperature to 80 degrees Celsius, the controller reduces its output. With a high gain and short reset time, it does so quickly. Place the simulator in hold. To see the controller's response in more detail, open the trend display specifically for the scrubber duct inlet temperature controller. Then zoom the controller output following switching the valve block to remote. Zoom again to see how the controller output changes each second. When the valve block is switched to remote, the controller immediately begins to decrease its output, the yellow pin. However, the control actions start from 87%, which is the requirement for a transition to be bumpless. The next video examines output tracking for the hot air temperature controller.